Hi there and welcome back to the Good Tutor SAT Premier Prep Program. And in this video, we'll continue looking at the Heart of Algebra subsection of the SAT math sections. And specifically, we'll take a look at graphing linear equations. All right, so before we can really get into physically graphing some linear equations, we'll have to go back to understanding that idea of slope, and specifically linear equations written in slope-intercept form, which of course we learned was y equals mx plus b, where b was the y-intercept and m was the slope of the line. Now, last time we said that the slope of the line determines how a graph moves, right? Or how a graph or a line moves. Is it up? Is it down? And how fast is it moving up, down? How steep is the line? And if you look down here into that bottom left corner, you'll see rise over run, the word rise over the word run. And that is how slope is expressed graphically. That means we focus first on how many we rise, meaning are we going up or down, and how many units. And then we're asking how many are we running to the right. For instance, if we had the equation y equals 3x plus 2, well, in the position of m is 3, right? And 3 as a fraction would be 3 over 1. And if we apply that rise over run, then that's really the same thing as calculating our change, or delta is that triangle symbol, change in y over our change in x. Meaning for every 3 that our graph went up, because that 3 was positive, our graph went right 1 unit. So we'll do one more kind of example of those real quick before we take another look at slope. All right. So if we had the linear equation y is equal to negative 4/5 x plus 3, then we would know that our slope, or the position of m in our parent form there, would be negative 4/5. And according to that rise over run like we learned, and we know we would be going down 4. So for every 4 units our graph went down, it would go right 5. And keep in mind, a negative sign like that will be applied to the numerator, or the rise, or in this case, going downward. But when it comes to the run of our line, it will always go to the right because we read a line from left to right. All right, so now we're going to take a look at what it means when two lines are parallel and or perpendicular. Well, I guess they can't be both, one or the other, right? When a line is parallel with another line and when it's perpendicular with another line. What does that mean for our slope? And again, in that form of y equals mx plus b. All right, so if two lines are parallel, they will actually have the same slope. And if you think about it, this makes sense because our slope is how our line moves. And if two lines are parallel, meaning they run next to each other and never touch, well, then they should be moving identically, right? And that is the case. So if we were to draw sort of a quick graph here with two lines on it, those two parallel lines could be two equations like this. Let's say 3x plus 4 and y equals 3x plus, or actually that one is below the origin, so we'll say minus 2. And in this case, although those aren't the exact same line, they do have the same slope, which means they will be parallel. Now, perpendicular lines, on the other hand, will actually have a slope that is the opposite reciprocal of the original slope, or opposite reciprocals of one another. And because they're perpendicular, so if we give that a quick drawing, because the lines are perpendicular, they run exactly opposite of one another, right? While one runs perfectly horizontal, the other runs perfectly vertical, at least in relation to one another. So an example of this would be y is equal to 3x plus 4. So now we look at that slope of 3 and we ask what is the opposite, meaning opposite sign, and then the reciprocal of a positive 3. Well, that would be negative as the opposite sign. And then 3, or 3 over 1, the reciprocal or the flipped version of that fraction would be 1/3. So negative 1/3 x. And then you could change the y-intercept to truly anything you wanted. You could even say +2. So those two slopes are the opposite reciprocal of one another, meaning the two lines that they represent would be perpendicular when graphed. All right, and now for this last portion, I'll actually graph a few equations on our coordinate plane here to just show you what it would look like to graph some linear equations. So if we go back to the simple example we had of 3x plus 2, well, in that case, our y-intercept, we know, again, in that form of y equals mx plus b, is a positive 2, or right there. And our slope of 3, or 3 over 1, means we'll be going up 3 and right 1 each movement of the graph. So 1, 2, 3 over 1. And then when we move in the opposite way, it will be down 3 and left 1. Something along those lines, and then we continue the line on like that. And that's not drawn exactly to scale because the line actually shouldn't be curved, but it should be rather a perfect line through each and every one of those points, more like that. And that's how you approach graphing linear equations. All right, that's it for this video. Up next, we have systems of linear equations.